Hi, ladies and gentlemen, this is Miss Skokin. We're back in Chapter 10, Section 2. This time we're going to be talking about inference for match pair design experiments. And you may remember those way back from the early part of the year, probably the first third of the year. We have talked about the confidence intervals for means and confidence interval for difference in means. And this is a different kind of difference because instead of looking at two different groups, we are looking at this kind of before and after situation. So for instance, let's say you're going to undergo a specific treatment. We take all the measurements, you undergo the treatment, and then we take the measurements afterward. Another example of the match pair or the paired inference could be that we put you in an experiment and you are your own control group. So you take both treatments, but what's randomized is the order in which you take the treatments. So those are the two types of inference that we would see. Let's take a look at what the data collection is for this example. Does memory training help? You will be given a list of words. You will be given 3 minutes to memorize as many as possible by just rereading the words. You will record as many words as you can remember. You will be then given another list of words to memorize for 3 minutes using a memorization strategy. You'll record as many words as you can remember. So what we would do if we were together is put you through both of the treatments. We would flip a coin to see which treatment each person got first, and then each of you would be given a list of words. You would use this rereading strategy first, or you would use the make up a story strategy first. So the idea would be you study the words by rereading. That's treatment group A. Treatment group B would be tasked with inventing a story with all of the words given on their word list to memorize. And then after each of the treatments, you would need to write down all of the words that you can remember from the list. So we would go through this process, and then we would record how many words you got correct using strategy A, how many words you got correct using strategy B, and then we would calculate the difference for each individual who received treatment A and treatment B. And we're doing treatment A minus treatment B. So once we get all of those differences, we subtract the data for treatment A and treatment B for each person. And then what we would do is we would put it onto a dot plot. So on the dot plot, we would only put the differences. Okay? So here you can see the dot plot of the differences of the data that we pretended that we collected because we can't be together right now. And we see if there's no difference between the two treatments, what the result was of how many words were memorized and then written down, we would see a difference of 0. If there is a positive difference, then that means that strategy number 1 was better because we did A minus B. If we have a negative difference, then it means that the second strategy, strategy B, was better. Altogether, we have 15 dots, and that means that later on we're going to be needing degrees of freedom, which is why I'm noting the sample size here. So what does the dot plot suggest about memory training? There are more dots above 0, and again, 0 marks the no difference, which leads to a positive average difference. Now you can see our X bar of the difference, our mean difference, and again, what you would do for this is find the difference, the A minus B for each of the different individuals, and put those differences into your list in your calculator. Run one variable statistics, get the mean and the standard deviation of the differences. And how do we interpret? On average, students remembered 0.333 more words with strategy A than with strategy B because we had that positive difference. The next thing that we want to do is construct a 95% confidence interval to estimate the true mean difference in words remembered by students using the rereading and using the story strategies. So remember that we're not finding the true difference or like we have in the past, or just the true value. What we're finding is the true mean difference, okay? Because we're using the difference column and then finding the mean of it. So what's the true mean? We start with state. We wish to estimate the true mean difference in words remembered with strategies A and B at a 95% confidence level. We know that our parameter is mu sub difference, which we defined as mu sub A minus mu sub B, or I'm sorry, mu sub A minus B. And then our statistic is x bar of the difference. Again, and we use the order A minus B. The plan, we're going to say if conditions for inference are met, we will construct a one sample t interval for mu sub difference. In terms of the conditions, random, the order of the treatments was randomly assigned. Remember, if we're not randomly selecting, then we can't say that they were randomly selected. But when we have an experiment, we want a randomized experiment where each of the subjects is randomly assigned to a specific treatment or placebo group. In terms of the 10% rule, we are not sampling without replacement, so the 10% rule does not apply. And for normal, the dot plot of the differences that I showed a few minutes ago showed no strong skew or outliers. So normally we would show the dot plot at this point when we're checking the conditions, but since I showed it on the previous slide, I did not redraw it here. Okay, next is do, and if conditions for inference are met, we're going to go through the general formula, which is point estimate plus or minus margin of error. The specific formula, our point estimate, is the mean difference, so x difference bar plus or minus t star times the standard deviation of the differences divided by the square root of n. Now, t star is going to be based on the degrees of freedom, which because we had a sample size of 15 individuals in our fake data, the degrees of freedom is 1 less than that, so 14, and the t star for 95% and degrees of freedom 14 is 2.145. We can find that on table B. So we plug everything into our formula, the point estimate plus or minus t star times the times the standard error, and we end up with this interval. Notice it goes from negative to positive. We know that that's going to be significant in a minute. So the next step is conclude. We are 95% confident that the interval from negative 0.807 to 1.473 captures the true mean difference in words remembered using the rereading method and using the story method. Just a reminder that every time we do this, we need to make sure that we do it in context. And you knew this next part was coming. Number 6 says, do we have evidence that there's a difference in the average word remembered using the rereading strategy and using the story strategy? And just as we have talked about in the past, it all depends on whether or not 0 is part of the interval. So just a little reminder on the left there, our interval does in fact go from negative to positive, so we have no convincing evidence that there's a difference. So because 0 is within the range of plausible values in our interval, we do not have convincing evidence that either the rereading or the story method is better for memorizing lists of words. That's pretty much our full state plan do conclude. And next it's time to write down the important information in our box. Typically, these match pair problems are going to have relatively small number of values, so it is reasonable that we would be given the raw data to work on and not the summary statistics to work on. So if we're describing that distribution, remember what we need. We need the mean and the standard deviation, and we would be able to interpret what that dot plot looks like if one is better than the other based on which side of 0 they're on. So it's always going to be interpreted in context. In terms of the type of inference, this is a one sample t interval for mu sub difference, because we're not looking at two different groups. We're looking at that before and after style group, or you are your own control group. Typically, if you see the same number of data points in the two groups, or what appear to be the two groups, then at least take a look and see if it's match pair design. If they're different numbers, you know you're working with two groups. If it's two separate companies, if it's two different times, there are certain ways that you can tell that it's two different groups, but every once in a while, we know it could be that matched pair design, and so that's what you want to be on the lookout for. When we have that match pair design, again, it's a one sample because it's means t interval for the true difference or the mu subdifference. And just as a reminder, there's our little formula for the confidence interval. Okay, there's a check for understanding here, and I'm just going to get you started on it and then recommend that you pause the video and work on it yourself. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which the subjects took the caffeine and the placebo was randomized. At the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression at the alpha equals 0.05 significance level. Look at all the information that's been given to us. We have our sample size. We know what the treatment groups did. We know what they measured at the end of the experiment. We know our alpha or level of significance. We know the direction. If we were going to run a hypothesis, we know the direction because they think it's going to be an increase. And in terms of our conditions, it says that the order of the treatments was randomized. Notice that our sample size is 11, so we are going to be looking back to see it does not tell us that they come from a normal population and the sample size is small, so we're definitely going to be graphing the differences. As we read through that, I hope you saw that each individual is going to be their own control group because they are going to have both treatments conducted, and in each case they're going to record their level of depression. What's randomized is the order in which they each get the treatment, the 11 subjects. So anyhow, the first thing that you're going to do, you need to establish the direction. Which group are you subtracting from which? And I propose that we say that the difference is the depression with the caffeine minus the depression with the placebo. And then the next thing that you're going to want to do is calculate the difference for each individual. Okay, I'm not going to say any more. Use the example that we did together as your guide. Turn off the video, and when you're ready to check your answer, turn it back on. Okay, so right up at the top, you can see I found the differences for each of the subjects, caffeine minus placebo depression scores. And then in number 1, it says make a dot plot of the difference in the depression scores for each test subject. So I did that using those differences. And since almost all the dots are negative, the placebo group had higher depression. And we can see all but one had a higher depression with the placebo. So the direction in which we define our problem matters. Part number 2 says find the mean and standard deviation of the difference, caffeine minus placebo, in depression test scores. Interpret the mean difference in context. So we put those into our calculator. We ran one variable statistics. We got the mean. We got the standard deviation. And our interpretation says on average, the placebo depression score was 7.3636 higher than for the subjects who took caffeine capsules. The next part says construct and interpret a 90% confidence interval for the true mean difference in depression test score. So our do, I know, feels very familiar to you by now. Point estimate plus or minus margin of error. We use the general formula. We plug everything in, including the correct t-star, which we found for 90% and degrees of freedom 10. And we ended up with a confidence interval that is negative to negative. Remember what that means. If we were asked for, is there evidence of a difference, then we would have to say no. Anyhow, to conclude, we're 90% confident that the interval from negative 11.143 to negative 3.584, remember our 3 decimal places, captures the true mean difference in depression scores between caffeine-dependent volunteers who took caffeine capsules and volunteers who took placebo capsules. The conclude very much in context. Keep that in mind all the time. That's it for now. Time now to move on to chapter 11.